All right, guys, welcome to lesson 2.3. We're going to spend 2 days on this topic. 2.3 is part 1, and then 2.4 is going to be part 2. And what it is about is combining functions. Okay, so sometimes in mathematics we like to take two different functions and put them together so they can accomplish a common purpose. Okay, so by the end of the day, you will be able to combine functions using addition, subtraction, multiplication, and division. And then we're also going to look at some word problems where you would want to combine some functions together, just so you can understand, like, well, what's the point of combining functions? Well, in a word problem, you can kind of see what the two functions are and why you might want to combine them together. And so we're going to interpret what these combinations would mean in the context of a word problem. Okay, so we're going to combine functions and then do that with word problems and interpret what that means in the context of word problems. All right, so let's go ahead and begin here. For example 1, I've given us 3 functions as equations at the top. F of x equals 4x minus 2. I've given you the g of x function here and this h of x function here. And numbers 1 through 5, we're going to be combining these functions. So let's go ahead and let's get down to business here. So, number 1, the function combination that we're working with is f of x plus g of x. So basically what it's telling me to do is it's telling me to add the two functions together. So I'm going to take the f of x function and I'm going to add it to the g of x function. So what is the f of x function? The f of x function is 4x minus 2. What is the g of x function? It's x squared minus 2x plus 1. And so now we're just going to add our like terms together. So the 4x can be combined with the negative 2x to give me 2x. The negative 2 can be combined with the 1 to make negative 1. And then the x squared doesn't have anything to combine with. And so there's our final answer. That is f of x plus g of x. All right. Let's go ahead and do number 2. For number 2, it's telling me to take f of x and multiply it with h of x. So, what is f of x? It's 4x minus 2. And what is h of x? It's 1 over x minus 3. Now, when you want to multiply fractions, because that's what h of x is a fraction, you're going to want both of them to be a fraction, and you're just going to multiply straight across here. So when you multiply 4x minus 2 times the 1 there, you're going to distribute the 1 into both of these, but that's not going to change anything. It's just going to keep it the same, actually. Same thing on the bottom. If we're multiplying x minus 3 by 1, it stays the same. So there's our answer for number 2. Let's go ahead and do another function combination. G of x minus f of x. So g of x is, of course, x squared minus 2x plus 1. And f of x is 4x minus 2. Now, when you are subtracting, you have to remember to distribute a negative in first. And that's going to change the signs of the 4x and the 2 there to be opposite. And then we're going to go ahead and just start combining like terms. X squared has nothing to combine with, once again. Negative 2x combines with negative 4x, this time to make negative 6x. And then 1 and 2 makes 3. And that would be g of x minus f of x. All right. Now, the last two have something a little bit different going on. Notice that it's not f of x and g of x anymore. Now it's f of 1 and g of 4. So now we are doing two things. We are evaluating these functions at a specific value. So for f, I'm going to plug in 1. And for g, I'm going to plug in 4. So I'm going to evaluate the functions first. And then after that, we're going to divide them. So let's go ahead and start. So if I have f of 1 over g of 4. The first thing I'm going to do is I'm going to take my f function, 4x minus 2, but instead of an x, I'm going to put a 1. And then for the bottom there, g of 4, I'm going to take my g function, but instead of an x, I'm going to be plugging in a 4. So this is f of 1 on the top, and this is g of 4 on the bottom. So let's go ahead and start simplifying this a little bit. 4 times 1 is 4, minus 2 is 2. 16, right, minus 8 plus 1. So that's going to be 16 take away 8 is 8 plus 1 is 9. So the bottom there simplifies to be 9. Remember, when you're simplifying expressions, you do order of operations first, right? You do exponents first, then multiplication, and then you do your adding and subtracting from left to right. But anyway, there it is. So 2/9 is the answer. Let's take a look at number 5. It's a similar thing. We're going to be evaluating as well as combining. So for number 5, we have h of 2 being multiplied by g of 3. So the first thing I'm going to do is I'm going to take my h function, which is 1 over x minus 3, but instead of x, I'm going to put 2, because we're plugging in 2 for x. Then I'm going to take my g function, and instead of x, I'm going to put 3. All right, so just got to watch your order of operations. I would say do each one of these things separate first. Okay, that'll help a little bit. So 1 over 2 minus 3. Well, 2 minus 3 is negative 1, right? And 1 over negative 1 is negative 1. All right, now let's go ahead and work with the g of x part now. So we have 9 minus 6 plus 1. 9 minus 6 plus 1 is 4. And so now we've got, this is h of 2, this is g of 3. Just go ahead and multiply those together. You've got your final answer is negative 4. Okay? So that is combining functions. And let's go ahead and have you guys give some of those things a try there. Go ahead and do numbers 1 through 4. Okay, so let's go and take a look here. Number 1, don't forget to distribute your negative. So if you didn't get what I have in the box there, maybe that would have been your issues. You didn't distribute the negative. But anyway, so there's the answer, number 1. Number 2, I'm being mean on numbers 2 and 3. I'm kind of expecting you guys to remember some old school math. Okay, so we need to multiply those together. Now, you could do it the FOIL way, which is first, outer, inner, last. Or you could do the box method if your teacher taught that. It doesn't matter which method you use. 4x squared times x is 4x cubed. 4x squared times 5 is 20x squared. 5 times x is 5x. 5 times 5 is 25. And all 4 of those are right there in our answer. And we usually like to put our answers in order from highest power to lowest power. So there's that one. Number 3, something else kind of weird happened. We had, when you plugged it 4 into the h, you end up with the square root of negative 1. Did you guys remember that's called I? It's called an imaginary number. Something you should have learned in Algebra 2. Hopefully you guys got to that. But if not, it's not a big deal. Anyway, so there's that. Number 4, I guess I was being kind of mean there as well. On all the examples I had, I never had a number in the front, right? What's up with that? Well, that means we're multiplying it. So what we're going to do is we're going to plug 1 in for x into the f function, which is what I have here. And that comes out to be 9. And then afterwards, you're going to multiply it by 2, so you get 18. Okay. Same thing here. We're going to plug 2 into the g function, and then afterwards, we're going to multiply by 3. So if I plug in 2, I get 5. When you multiply it by 3, you get 15. So we ultimately end up with 18 take away 15, which is 3. Okay? So that's function combinations. All right. So now we're going to go into some word problems. Like, so why would mathematicians want to combine or functions together? Well, word problems can kind of give you a little bit of maybe an understanding about why that might be useful. So let's read this really quick. The width of a rectangle increases over time according to this function, W. Okay, so what this means is, let's say that t represents time in seconds and W of t represents the width of the circle. So for instance, at t equals, let's say 2, which is like, I don't know, we'll say seconds. At t equals 2 seconds, if I want to find out what the width of my rectangle is, I would plug 2 in to this function. And the answer is 9. So at 2 seconds, after 2 seconds have gone by, the width of my rectangle is 9. Now what if I okay, well, how wide is my rectangle at 5 seconds? So now I would plug in 5. And that would be 15. So it looks like the width of this rectangle is increasing. As I went from 2 seconds to 5 seconds, the width of the rectangle went from 9, I guess we'll say centimeters, to 15 centimeters. So the width of the rectangle is changing. So just imagine seeing a rectangle here, and over time it's getting wider and wider, etc. So the width is increasing. All right, so that's what this means. So we have a function which describes the width of your rectangle over time. Now in the same way, the length of the rectangle is decreasing over time according to this function. So rectangles have length and width. So the width is increasing, but the length is decreasing. So we could use the same times. Let's see. What is the length of the rectangle at 2 seconds? Well, the length of my rectangle at 2 seconds would be 20 minus 2, which is 18. So at the 2 second mark, the width of my rectangle is 18 centimeters. What about at 5 seconds? How long will the rectangle be at the 5 second mark? We're going to plug in 5 into the L function, and it's 15. So it went from 18 centimeters to 15 centimeters. So it's decreasing in its length. So we have this rectangle which, over time, the width is increasing, but the length is decreasing. So, at t equals 2, it might look like this, but at t equals 5, it's going to be skinnier and taller because the width increased, but the length decreased. So we have this weird rectangle that's changing its shape over time, and we have these two functions now that are telling us what the width and length are of this rectangle at any given point in time, right? So what has it got to do with what we're learning today? Well, today we're learning about combining functions, right? So I've got two functions here. Now let's read the next bullet here. The next bullet down says, write a formula for the area of the rectangle. Now, how do we find the area of a rectangle, you guys? That's important, you know that. How do you find the area of a rectangle? The area of a rectangle is, as you know, length times width, right? So the area of my circle is length times width. But the length and width of this rectangle are constantly changing over time. So instead of just saying the area of my rectangle is L times W, I'm going to say that the area of my rectangle is L of t times W of t, which means that the area is constantly changing as well, right? If the length and width are constantly changing, then so is the area. So the area is not just a number now. Now it's a changing number, which means it's a function. It's a variable, right? So here is kind of my answer. We have A of t is equal to L of t times W of t. But we can go a little bit further than that. If A of t is equal to L of t times W of t, in other words, area equals length times width, we can replace L and W with what they are. What is L? L is 20 minus t. What is W? 2t plus 5. We could write that as well, right? And then we can go ahead and actually simplify this. So if you want to use the box method or the FOIL method, it's up to you. I'm going to do the box method up here a little bit. So we have 20 minus t being multiplied by 2t plus 5. So 20 times 2 is 40t. 20 times 5 is 100. Negative t times 2t is negative 2t squared. Negative t times 5 is negative 5t. And so we have the following. The four numbers I got in my box up there are negative 2t squared. I like to put the highest power first. Followed by 40t minus 5t plus 100. And we have some like terms that we can combine here, right? So now I have a new function, a new formula that I got by combining two other ones. And this new formula can tell me what is the area of this rectangle at any given point in time. Okay? So that's one example of why a mathematician might want to combine two functions. Okay? So let's say we have a rectangle whose width is constantly changing and whose length is constantly changing. Well, that would mean that its area is constantly changing because area is length times width. If area is length times width, then area would be this function times this function, which when you simplify it would give us this. So that's an example of combining two functions and understanding what that represents. So let's go ahead and have you guys try one of these really quick, okay? I'll read it to you, I'll explain it to you, and then I'm going to let you guys do the math and see if you can come up with the new combined function. So here we are. The profit for selling tickets to N people for a fundraiser is given by this. So my first question to you would be this, is what does N represent? People. And what does T of N represent? It's the profit. So what's going on here is that we're selling tickets to people. And over time, the more people that come in, the greater my profit is, right? Obviously, if more people are buying tickets, the more money you're making. So for instance, let's say there was 10 people. Well, that means that I would sell 5 times 10 minus 100, which is negative 50. Now, that means my profit is negative. That's kind of weird, but actually when it comes to business, that happens. When you start a business, sometimes you have to put money into your business, and it will take you some time to actually make enough money to pay off what you put in before you start making more money. So, but that doesn't really matter right now. What I want you guys to understand is that N is people and the output is profit. And so if you plug in a number of people, the output will tell you how much profit you've made. Okay? Next one, snacks will also be sold. The profit for selling snacks to N people is given by this. So, pause the video if you need to and think about this. What does the N represent and what does the S of N represent? What does this function tell you? So think about it for a minute, and when you unpause the video, I'll continue my explanation. Well, N still represents people, but S, the output, S of N, represents the amount of money you get from snacks. So we actually have two profits now. We have profit from snacks, so we're making money by selling snacks, but we're also making money by selling tickets. So we have two ways that we're making money now. All right? So if you want to, let's say if you sold 20 snacks, right? You would plug in 20 for n, 2 times 20 minus 50, and that'll tell you how much money you have so far. Okay? Now, that aside, that's what the functions are. Those are the two functions I'm giving you. Now, you're going to be combining them. This says, write a formula for the total profit of the fundraiser. Now, I want you guys to understand, we're combining functions. There are four ways that I've told you we're going to combine functions today. Adding, subtracting, multiplying, and dividing. Okay? On my example that I gave you guys with the rectangles, we multiplied because that's how you find area, right? Base times height. You're not going to multiply on this problem. How would you combine these functions to make a formula for the total profit? See if you can figure it out. Write your answer and simplify it, and when you unpause the video, I will go through the explanation and share with you how to do it. Okay, so write a formula for the total profit. Well, we have two sources of profit. We have tickets making profit for us, and we also have snacks. If you want to find the total profit, wouldn't you want to take the profit from the tickets and add that to the profit of the snacks? So we're not multiplying this time, we're not subtracting either, and we're not dividing, we're adding the two functions together to find a formula for the total profit. So the total profit is the tickets plus the snacks. So I'm going to create we'll just call the total f, okay? So f of n, which represents the total profit, is the profit made from the tickets plus the profit made from the snacks. Okay? So if the total profit is t of n plus f of n, then f of n is going to be equal to f of t of n, which is 5n minus 100, plus s of n, which is 2n minus 50. And then if we go ahead and combine those together, we can have a simplified formula, which now tells us, that new formula there will tell us how much money we make after n people come to our event. Okay? And that would, of course, be assuming that everybody who comes to the event buys snacks also. If that weren't the case, then you couldn't combine these together because the number of people buying tickets would be different from the number of people getting snacks, and therefore you really couldn't combine these like that as though they were the same thing. But that's just kind of extra information that doesn't need to be said. But what I want you guys to notice is that you need to understand what these mean to begin with. And then you need to understand how to combine them to create the formula you need. After that, you just simplify it. It's just like what we did earlier. So a little bit more of an interpretation thing is involved there. So now let's continue our talk about interpreting things, just so that these things have a meaning behind them to us that we can understand. All right, example 3. The amount of time Alex spends at school when taking X classes is given by the function t of x. So I'm going to make some notes on the side here. X represents the number of classes he's taking. Okay, it says X classes. So X represents the number of classes that he's taking. What does t of x represent? Well, that's the amount of time he spends at school. So t of x is time spent at school. Now, as we learned a couple lessons ago, how would you say this verbally? You would say that t is a function of x. Or you could say that t depends on x. Now, in the context of this word problem, then, we could say that the time Alex spends at school depends on how many classes he's taking, right? All right, let's continue. So we've interpreted those two. The amount of time Alex spends on homework is given by the function h of x. So now we have a new function, h of x. Time spent on homework. And in the same way, homework is a function of x. So in other words, the number of classes that Alex is taking will affect how much time he spends on homework, right? So what we're being asked to do here is we're being asked to interpret the meaning of each one of these expressions here. Okay? What does this mean then? What is t of x plus h of x? Well, basically what it is it's the time that Alex spends at school added to the time that Alex spends on homework. So how would you interpret that? Well, basically, an easy way to say that is the total amount of time Alex spends on school-related stuff, right? I mean, you're either at school or you're at home doing homework, right? So if you put those together, that basically just tells you the total time that you're spending on school stuff, right? Let's take a look at this one then. Well, first of all, I want you guys to notice that there's a key difference here. There's a 5 in here where the x is. You guys remember what x represents? X represents classes. So apparently what this is saying is it's saying that Alex is taking 5 classes, right? And t of 5 would represent the amount of time he spends at school taking 5 classes. H of 5 represents the amount of time he spends on homework when he's taking 5 classes. So what the heck would subtracting those things tell you? Well, if this is the time spent at school with 5 classes, that's this one, minus time spent on homework with 5 classes, what would subtracting those two things tell you? You know, so like let's just say, for instance, that you are, you know, you're taking 5 classes, you know, and let's say that because you're taking 5 classes, let's just say maybe you spend like maybe 5 hours at school. But then you go home and you do your homework for those 5 classes, and it takes you 3 hours. So 5 hours at school minus 3 hours of homework, what does that tell you? What does this 2 mean? Well, that would mean that's how much more time you're spending at school than you are on homework, okay? So really weird stuff, but just want you to start to think about what these symbols represent. So I would say, if you subtract those, it would say it's the difference between the time Alex spends at school and the time he spends on homework. When he takes 5 classes. You have to include that because they do have that 5 in there. So you need to make sure you interpret the 5 as well. So what this means is this is the difference in the time that Alex spends at school and the amount of time he spends on homework when he's taking 5 classes. Okay? All right, let's go ahead and do another one here. Number 2. So remember what I did here on number 1. The first thing I did was I looked at my 3 variables that I had, x, t of x, and h of x, and I interpreted those separately. and then I started interpreting the combinations. And so that's what I would have you guys do here. So for a minute, take a minute here, and I want you guys to tell me what are the 3 variables for this problem. Think, if you need to, pause the video and think about it for a minute. What are the 3 variables in this word problem? All right, the 3 variables are t, a of t, and p of t. Now, what do they mean, though? T is what year we are in. Okay, so I don't. It's not really telling us what year we're starting with, so it's kind of hard to say. Is it the number of years after 2000? Is it the number of years after 2010? I don't know. It doesn't say. But t just represents a certain number of years that have gone by. Okay. Now, what does a of t represent? A of t represents the number of people that have A's in that year. The number of people that have A's. And what does p represent? P is the total number of people at the school in that year. So A represents how many A's there are in the year T, and P represents the total number of people at the school in the year T. Okay, so let's go ahead and start with something a little bit easier. Part B is, I think, a little easier than Part A. So let's go ahead and take a look at Part B. What does that 4 mean? First of all, you have to recognize that 4 represents a t value. And if it represents a t value, it must be the year that we're in. So this is the 4th year, whatever that means. It represents the 4th year. So what does P of 4 mean? P of 4 means the total number of people in the school at the 4th year. What does A of 4 mean? A of 4 means the total number of people that have A's in the 4th year. So what do we get if we subtract them? Well, there's a few ways you could say it. You could say it's the difference between the total population and the number of people with A's in the 4th year. Or another way you could say it is if you take the number of people that have A's away from the total number of people at the school, what is the rest of the population that you're talking about there? Well, those are people that don't have A's, right? So if you put these together, what that tells you is the number of people who don't have A's in year 4. Okay? So if you take the total population and you subtract from that the number of people that have A's, that'll tell you how many people don't have A's. And we're doing that for the 4th year. All right. Let's take a look at Part A then. Part A. So we're taking the number of people that have A's and the total number of people at school, and we're dividing it and multiplying it by 100. Now that's kind of tricky. What would that mean? So let's say that there were 100 people that had A's, but there were 400 people at the school, and we multiply this by 100. Well, 100 divided by 400 is 0.25, and if we multiply that by 100, we get 25. What does that tell us? That's a percentage, you guys. So basically what that's telling you is if you take the number of people who have A's and divide it by the total, multiply by 100, that's going to tell you the percentage of people that have A's at the school. Now, that's kind of tricky. I won't be giving you stuff quite that tricky on your test, but things that I think that should be pretty chill would be adding, or like the area problem I gave you. Those are things that I would expect you to do. This one's just making you think a little bit. But what this represents is the percent of people who have A's at the school. And since there's nothing being plugged in for T, it's not telling me the percentage of people who have A's at the school at some particular point in time. It's just a formula that will tell us the percent of people who have A's at the school at any time we want to plug in. All right, so there's the interpretation. Why don't you guys go ahead and give this one a shot. Pause the video, do all 4 parts, and when you're done, unpause it, and you will see Mr. Bailey's interpretations of these things. Okay, now these are what I would call fair questions. These are questions that I would expect you to be able to give some reasonable answers to. The last slide with the percentage one, that was a little tricky. But here we go. So for the first one there, T is years, P of T is the population of California, M of T is the average income of each person. So part A, what's P of T times M of T? What does that mean? Well, that means you're taking the total population and multiplying it by the average income of each person. So, you know, if there was like 100,000 people in California, which is definitely way, way, way more than that, and let's say the average person makes, you know, I don't know, $50,000 a year. Well, if you multiply the amount of money each person makes by the number of people, that's going to tell you the total amount of money that was earned in California for any given year. Okay. Now, part B is the same question as part A, it's just that I replaced the T with a 3. So it's the total amount of money earned in California, but specifically in the 3rd year, because a 3 represents a T. Now, number 2. The T in this problem represents the year once again. The P represents how much money you make in this business, and the S of T represents how much money you spent. So what is P of T minus S of T? Well, it's the amount of money you've earned minus the amount of money you spent. And so what we call that in the world of business is profit. Okay? Now, if you didn't use that word, that's fine. Maybe you said it's the difference between the money earned and the money spent. That would be perfectly fine as well. Part B, though, is in the 2nd year now. So what this would be is the profit that was made in the 2nd year. Or you could say it's the difference in the amount of money that was earned and the amount of money that was spent in the 2nd year. So those are your 2 ways of interpreting that one. And I think that does it for our lesson for the day. So till next time, we'll see you guys then.